Okay, so we're getting there. Thank you for those that have been here throughout the day and people that have been coming and going. What I want to do is talk about in this panel with our panelists plus Benji, four-legged friend. So I want to talk about an important topic to us at Blockswap. It's security, a security-first mindset, security from day one or day zero, if better. And so we've got Chandra from Certora, Everett from Runtime and Chainsecurity, Dominic. So what I would like to do is give you guys opportunity to introduce yourself properly, sort of what areas in security you're working on, and what does security sort of mean for you? Yeah, I think you might need to switch on. Yeah, cool.
Cool. Hi, thank you. My name is Chandra, and like you said, I'm from Certora, and I am part of the research team there, and most recently I've been working on a mutation testing tool, actually. So the idea is that when you write your specifications, it's important to get the intent you had for your program to be correctly encoded in the specification, because if you have a bug in your specification, then the results of formal verification cannot be trusted. And so we've been building this tool called Gambit, where you can automatically generate mutations for your code and then verify them against the same specification, and make sure that the spec is. It gives you some confidence that the spec is good enough. And we're also sort of more recently working on another tool, which is sort of a more dynamic tool. So so normally when you do verification, like the Certora style verification, it's static, right? So you do it once and you deploy your code and so on. But we're trying to work on something that will do this more and more frequently. So like dynamic monitoring of the state of the blockchain.
Thank you.
Yeah, hi everyone. I'm Dominic Bruetsch. I'm one of the lead engineers and founding partner of Chainsecurity. So the description on the slide is not entirely accurate. I'm working with smart contract audits since 2018, mainly EVM-based chain, but also Darknet and some others. On top of that, I'm educating new auditors getting into the job. Yeah, and I'm really passionate about IT security in general. For blockchain applications like smart contract, I would simplify it down. Security for me is that the code does exactly what it's specified to do and nothing else.
Hello, I'm Everett. I'm from Runtime Verification. And yeah, I mean, we've been working on formal verification for a while. From before we were in blockchain, we were working on a lot of testing tools in aerospace and automotive. So RV is primarily a technology company. We've gotten big in blockchain for auditing services, which are formal verification based, which I think actually several other audit firms have benefited from the reports we produce, which produce these very nice design models that can be used for formalizing the protocol in other tools or in our tools. More recently, we've been working on kind of getting the 80% of Solidity developers to be able to access something like 40% of formal verification. So not focusing on the highest power applications of our tools, but on the broadest applications of our tools. And that's what our K-Foundry integration is really about, which Grigori talked a little bit about earlier today. So,
awesome. Thanks. Definitely really, really interesting. The industry is moving sort of more to helping people get higher assurance about their code. As auditors, or offering, auditing services, Everett and Dominic, sort of, what do you think in 2022, sort of, maybe not necessarily smart contract developers, maybe as an industry as a whole, what did we do well, and where did we win, and where did we lose? Like, is there a common theme, or is it just not enough easy access to tooling? What do you guys think?
Actually, access to getting an auditor, becoming an auditor, got way easier with all the incentive and programs that started. So that's a very good sign. So we have way more people capable of looking at code, finding issues. that helps the whole space.
What was the catalyst, do you think? That
the Ethereum bootcamp, for example, all the A4 challenges, but also all these audit contests, which are readily available for everyone. Everyone can simply participate, find bugs, submit bugs, and have fun looking at the code, trying to break stuff, submit a report of the issue, and get a reward. Yeah.
Awesome.
I think, as I said at ETHDenver, and I think also at DevCon, the amount of tools that are on the market now is just staggering compared to what was available even 3 years ago. So at this point, it's on devs if they're not going out and learning how to use tools and figure out how to achieve their quality assurance goals. That being said, I do think that there has been still a bit of a lack of education and documentation about a lot of these tools. One company that I think really excels at that is Certora, actually. So congrats. But I think that the big win is that there are tools available. I think the big loss is people still aren't using them as much as they could be, and they're still kind of treating auditors as like this, magic black box that's gonna find all the bugs for them. And it's like, okay, you could also go and learn how to do this yourself, and then the auditors could focus on making their tools better instead of just on reviewing your code.
Yeah, and an auditor is definitely not a magic black box that can fix all of your problems shortly before deployment. Security starts way earlier, way before the first line of code is written. You should think about what you want to implement, about your specs, about your trust model, and security starts there.
Totally agree. Totally agree. I think as a team, you should try and catch the low-hanging fruits as early as possible. Hopefully, like you said, Everett, the documentation and the education continues to improve, encourages more auditors into the space, but also more skilled developers. Hopefully, the tools get better. I've seen with, if I compare Foundry compared to the Truffle smart contract development framework, the level of development tools, but also testing tools. Fuzzing is now out of the box with Foundry. It's something that we take for granted, but it's just there. But that's great. Pre-development, you get your audit, you deploy your smart contracts to mainnet. Do we just forget about it and go home, or do we continue to see is the system behaving as expected? I sort of throw this out to all of you guys. So what happens post-deployment? What kind of tools can we use? Where do we go?
Yeah. So I think that there is value in, even after deployment, trying to monitor the contracts. This is actually something that we, like I was mentioning earlier, is something that we're trying to focus on a little bit more. You verify your code once and then you deploy it, and you shouldn't really just forget about it, right? Because one of the things that can happen, for example, is if you're linking with some external library or something, right? Or things that you didn't really actually verify. And when you actually deploy your code, all these unknown factors come in, and it's really hard to know if the properties that you statically verified are still true or not. And so I think there is value in sort of running your verification tool somewhat continuously, even after deployment, on concrete instances of the blockchain. So something like a monitoring or runtime checking.
Right, because with the Certora static analysis, you're sort of it will deploy a contract to in a simulated environment, and it will check it behaves as expected. But I guess you could do that against deployed contracts, right?
Yeah, that's something we're working on right now. But I think there is value in that.
Cool. Right.
Definitely. Apart from what was just discussed, it's also verify the deployed bytecode if it's the expected bytecode, checking the initialization, and then monitoring the operation of the smart contract, especially for large DeFi applications where you had certain assumptions on how certain actors behave so that the whole system is balanced. Monitor your smart contract if that actually holds in practice.
Bytecode can catch people, especially for new developers.
I actually only know the opposite, the Rect leaderboard, which lists hacks and the responsible auditor.
It's kind of like you're asking sort of, you know, so countries have like is it Moody ratings? You know, it's like Moody or I don't know what it's called, but it's like grade A, grade, you know, B, kind of, you know, how well they manage the finances. You know, you want to do something like that. But I think these databases are developing not just on the companies themselves, but a lot of people, like, there's these websites, audit-hero.com, and it's people trying to list what are common vulnerabilities, where do things commonly go wrong, you know, things that happen time and time again that, you know, people should be making sure that their system does not fall prey to those issues. Right, right. Sure. Sounds like a business idea.
Yeah, there's a couple I know, just to answer the question. The question, by the way, I think we should repeat for the mic, is there a database of contracts that are highly vetted or highly approved or have had verification done on or something? There's a couple of tools. Yeah, there's a couple of tools that I have heard of. One was Certora.live. I think that was released by the Hackin team. So CER.live. I don't know if it's still up. It was a while ago. Then there was the DDAUB contract library, if you've heard of that. DDAUB, D-E-D-A-U-B, contract library. I think that's a very good one. And then we also have, specifically for the ERC20s and other ERC standards are coming, the ercx.runtimeverification.com. So it's ercx.runtimeverification.com. That one is, you know, contracts on mainnet, put in the address, and it'll give you kind of a overview of, that's for ERC20 specifically, so it's not going to be general like the other ones I listed, but that could be kind of a nice one to look at. Yeah. But sorry, what was the original question?
It's just post-deployment life cycle.
Yeah, post-deployment. So yeah, I think that's an excellent point you brought up, actually, validating that the deployed contract is in a sane state when you're starting it, right? Because there's a lot of weird transient issues that come up if your contract is deployed just slightly incorrectly, you know, and so it's good. Deploy, don't really announce, check that all the parameters are good, then go from there. One thing I would really like to see is, you know, doing these audits, we're often identifying important properties that must hold in the protocols. So these are going to be invariants or temporal properties or other things like that, and those are written down in some formal or rigorous language. It would be nice if you could just extract the monitor. I actually wanted to get Chandra's opinion on that last statement as well. Like, state the properties once and then monitor them. Do you think that's valuable? Do you think it's viable also? Will the Certora tool be able to do something like that? Or?
So just have the property written once and then
the same property that you verify. I mean, you assume that since you verified it's holding, but you know, we find bugs in these tools all the time.
No, I think, for sure. I mean, like, you know, like as I was saying, like sometimes when you do verification, you're not necessarily, you know, verifying all the code, right? You're probably like verifying some part of the code, and then when you actually deploy, you know, you want to make sure that the property still holds, like, you know, on real storage values and things like that. Another thing is, it's also actually valuable. For example, if let's say that the property is really hard and you just simply can't verify it, right? You don't have to just give up, right? Like, you can just try to see if the property holds on like concrete, you know, values that you can get from the blockchain, and that's something that's, I think, valuable, right? Like, it's better than not doing anything.
Yeah, or if you verify on a model of the system instead, like make some simplifying assumptions, the verification goes through there. Okay, there's a little bit of a gap there.
I think for runtime verification, I think that, you know, seems like something that would be cool.
Awesome. So for Everett and Chandra, so I touched upon how, like, with Foundry, you have now you have fuzzing out of the box. It's just, you know, you're writing solidity tests, and you can just, you know, activate fuzzing really easily by making your test parametric. How do we get to the point where formal verification could be just switched on at a push of a button, you know, and it's part of the, it almost feels like, because with fuzzing it feels like a unit test, but it's, you know, it's doing across more, you know, sampling of the inputs. You know, how do we make this super easy just so that it's like accessible to as many people as possible, you know, from a tooling perspective?
Right. So I think one thing is, I think what Dominic was saying, this kind of, you know, competitions that are happening, like the, I think Armin recently did this code arena thing, which was quite successful. Where, what's that? Oh, you guys did it. Never mind.
With you guys,
right?
Yeah.
Okay. So like that was, you know, that's I think that kind of thing has a lot of value. Also, there's, you know, other interesting ideas that I think are kind of worth you know, trying. Which is, for example, let's say you wrote your tests. Like, I think maybe you were mentioning this, like how can you extract a specification from a test, or, you know, so like something like that, right? Like you don't have to write the whole specification from scratch. Like maybe you can get some hints from tests, you can generalize it.
Definitely, you know, compilers, the Solidity compiler today will try and, you know, give you hints about what's going wrong. You know, the ROS compiler does that as well. So kind of giving people hints would be helpful, because there's a big learning curve associated with formally verifying your smart contracts. There's, you know, a lot of people don't know what an invariant is. You know, this is, you know, there's a big learning curve associated with it.
I mean, I have talked about it before. I'm a big fan of property testing. I think it gets the 80% of people to start just thinking about what it means to specify things. Admittedly, the property tests that people who don't have the formal methods background are writing are not the same caliber as what we're producing for clients, for example, right? Like we actually, you know, that just comes with practice, right? That's just, you know, being able to sit down and think about, like, have all the paths been explored? That type of formal methods thinking, that's not something that you're born with. You know, you have to learn that process, and people who go through like a formal methods PhD learn that process in depth. But, you know, I think it gets people to start thinking about it, right? Like just start thinking like, what is my specification? What is it? And write it down in code, and then maybe start extracting it to something a little more formal after that. So definitely a big fan of that. I also think that a lot of formal methods tools struggle from just normal software development pains, like it's hard to install, there's so many dependencies, there's like, you know, this type of stuff that just, you know, can stop people from trying a tool in the first hour. You know, like you're trying a tool, can't resolve this dependency, done. Not gonna do it because I can't get Z3 built on my system or whatever. I think the CI integration is key for that, right? Like you just somehow have a GitHub action or whatever, calls out to some other service, that service is running, and it, you know, it's already got the tool installed, it's got the environment configured, comes back with the result, you're done, right? Like you don't have to ever install anything on your own system. So I think that's one thing that we can do, is like this CI integration thing. Yeah, I don't know. Like
static analyzers are now quite commonplace for people, right? But it, you know, it's served on a platter to people, you know, in like a Docker container, already set up. That sort of, you know, that sort of level of easiness, I think that definitely is true. And what you said about stuff not being natural, like writing property tests may not come naturally to developers who are maybe more used to writing unit tests, which are more scenario specific. You know, Alice does A, B, and C, and then this thing happens. No, I do agree, and it's very much like, you know, I look out on the cars, but you know, driving is not, you know, humans aren't really, you know, biologically, you know, designed to drive, but with practice, you get, obviously, you know, you can get to that point, right? So where you can drive. So I do understand that element of that.
Yeah. I had one more idea I wanted to expound on that I remembered, sorry, which was integrating into other tools, right? So that the one tool that I think is overlooked a lot in this community is the Solidity SMT checker, which is built directly into the Solidity compiler. Turn it on with a command line flag. If it is able to get you results within a few seconds, it does, right? Like about whether your assertions are reachable. And if it's not, it doesn't get in your way. It doesn't stop you from building the contract or something like that. You still can compile it, deploy it to the chain, but if it can find a counterexample for you, like, hey, this assertion is reachable, that's an actual bug, right? Like you can immediately use that. So I think anything that's a static analysis tool or something that can run in under a few seconds, we should just be building it directly into people's compilers, into their IDEs, whatever it is, and not even tell them that we're turning it on, right? We'll only have it give the error message when it's a problem.
So why do you think it's not got to the point of being switched on by default? Because things like now with Solidity version 8, things like safe math have been finally enabled. It took a very long time to get to the point where safe math was enabled by default. And if you're not careful and you built in Solidity version 8, if you built your smart contracts without any safe math libraries, like maybe from OpenZeppelin, you're subject to under or overflows, right? And that can lead to bad things. So is it just, trying not to, go softly and not trying to break things, or, should we be forcing people to do things more safely? What should we do?
I don't know. Maybe we need like a pedantic mode for the compiler that turns all these things on. I'm not sure.
Right.
I think it is that we're going softly and trying not to break things. I think that's really the problem. But I mean, it's a safe approach.
Right. Yeah. Right. Yes. So I'll just go something random. Just to finish this off. This has been a great panel. Just to throw it out to you guys, aliens, real or not? Are we alone? Is there anything out there? What do you think? No right answers, yeah.
So I've been watching this show called Orville recently. I don't know if you guys know this show. It's so I'm a little biased at the moment because it's a really good show, and it makes me kind of think that maybe there are other creatures there.
Awesome.
Yeah, sure, why not? And maybe they've even figured out decentralization already.
Yeah, I think it's probably pretty likely, yeah. I don't know if you've ever read the Dark Forest trilogy, but that was where the Dark Forest MEV post came from, and it's a pretty good read as well. So why would aliens let you know they exist, if they do exist? Because that's kind of the theme of the book. So
yeah, if we're in the Matrix or something, right? Okay. Yeah, that was awesome. Yeah, thank you to you guys for coming on. And yeah, thanks to everyone that attended.